Assalamualaikum students. Students, in this class, we are going to start the electrochemistry. This is the first lecture of the electrochemistry, right? What is electrochemistry? Electrochemistry deals with electrochemical cells. Electrochemical cells are of two types. Electrochemistry deals with what? Electrochemical cells, which are of two types. What are these two types? Number one, simple cell. Number two is what? Electrolytic cell. Simple cells and electrolytic cells. Simple cells contain, like we use voltmeters to measure the potential difference of the two electrodes. But in electrolytic cell, you will see power source. In both, there is redox reaction. In both, there is a spontaneous redox reaction. That generates electricity. Generate electricity. In this case, there is non-spontaneous redox reaction that need electricity, current. Now, whether it is simple cell or electrolytic cell, both contain two electrodes. Like this is a cell. A cell. Both the cells contain two electrodes. You can say two half cells. In all cells, there are two half cells or electrodes. In all cells, there are two half cells or electrodes. And one half cell, if oxidation occurs, at the other half cell, reduction. Now the decision of oxidation and reduction is done on the basis of standard electrode potentials. What? The decision of oxidation and reduction is done on the basis of standard electrode potential values, which are called what? E naught values. E naught. These values, these standard E electrode are given in data booklet along with electrode equation. These E electrodes are given in data booklet along with electrode equation, and now they are given, in question, right? The E electrode values, these E electrode values, like suppose if I define them, standard electrode potential, standard electrode potential are measured relative to standard. This I'm going to explain later on. First, just write it. These electrode potential values are measured relative to standard hydrogen electrodes under standard condition. Conditions: 25 degrees Celsius, 1 atmospheric pressure, and 1 mole per dq concentration. Now, both the cells are made up of two half cells, two electrodes, and these electrodes either oxidation occur or reduction occur, but these oxidation and reduction are decided by standard electrode potentials, which are measured relative to standard hydrogen electrode. And like the main point that you are supposed to use it again and again is if the E naught value is large. If E naught value is large, reduction occurs. Larger E naught, reduction, smaller E naught, or we can say larger E naught, there is gain of electron, reduction, and stronger oxidizing agent. Lower E naught, loss of electron, oxidation occurs, and stronger reducing agent. Right now, I am going to fully explain this. Look, in your data booklet, they will give you this type of situation. If you look at this, this is, just look at this one. Just compare these first up to this, okay? The one which you can see right now. Like I'm going to explain this. If you see, this one is gaining electron, +2 electron, gaining electron, gaining electron, gaining, This gain how many electron? Huh? It's different in each case. Silver is gaining 1, aluminium is gaining 3, this is gaining 2. So they gain electron. So in the forward, if you see, these are all reversible reaction. Silver is gaining, but silver metal is losing. Aluminium 3 is gaining, aluminium metal is losing. Barium is gaining, barium metal is losing. Bromine is gaining, this is losing, gaining, lose. So in all the forward, there is gain of electron reduction. There's what? Reduction. The forward is reduction, the backward is oxidation. Reduction, oxidation, reduction, oxidation. So they're all gaining electron, they're all get reduced. Look, they all gain electron, they get reduced, they're oxidizing agent. They are oxidizing agent. But what about this side, the other side? They all lose electron. They get oxidized. And they're all reducing agents. Huh? Like it's not just this. This is the whole, the information that I've given in your data booklet. If you look at all these, look. This gain, this one lose, this gain. So on this side, they're all gaining, they're all losing, they're all oxidizing agent, they're all reducing agent. But how do I know that which one is stronger oxidizing, which one is stronger reducing? From these E naught values. These are called what? These values are called what? Electrode potential values. These are called what? Electrode potential values. All these electrode potential values are measured relative to standard hydrogen electrode. This is the reference electrode. All these values are measured relative to standard hydrogen electrode. Now, how they are measured, this we will explain later on. But right now, if you see at all these equations, what you can find? That all these are gaining, all these are gaining, but on the other side, they're all losing. These are all losing. The forward is reduction. The backward is oxidation. They're all oxidizing agent. They're all reducing agent. And their strength depends on what? The value. The larger the value, look, large E naught, more is reduction. Larger E naught, like for instance, if I compare only these four, among these, which one has larger E naught? See, the 1.36. So among this, which one have more tendency to gain? Chlorine. And among these, which one have more tendency to lose electron? The one with the lowest E naught, barium, minus 2.9, right? So in your question, they will give you the E naught values, the equation, everything, and you are supposed to know that which one will gain under certain condition and which one will lose. This is decided by what? This is decided by these E naught values, right? For example, if I just take this to the other page, wait a minute. Then I can't copy it. Okay. Listen. So what I've written, that these electrode potential values are measured relative to standard hydrogen electrode, and larger the E naught, more is the gain of electron reduction. Lower E naught, there is loss of electron. The one that gain electron get reduced, stronger oxidizing agent with the larger E naught. Now, suppose there is this beaker. In this beaker, suppose there is this chlorine gain electron, making chloride. There is this barium 2 plus gain 2 electron. Barium, its E naught value is 1.36 volt. It is minus 2.90. MnO4, I'm writing another one. Okay, iron 3, gain electron, iron 2 plus 0.77, bromine, gain 2 electron, plus 1.07, MnO4, 8H plus 5 electron, Mn2 plus 4 water plus 1.52 volt. Suppose they are all in the beaker. They are all present, You know, these are all gaining electron. So they're all get reduced. They're all getting reduced, and they're oxidizing agent. And these are all the one that can lose electron. They get oxidized. They're all reducing agent. Now, which one will gain electron? The one with the larger E naught. So among these, which one have the largest E naught? MnO4. So you know what will happen? This one will gain electron, go in the forward direction. And which one among these will lose electron with the lowest E naught, stronger reducing agent? This is this barium, it will lose electron. Now, this one would gain, this one will lose, the other would be spectators because they are the winner of the gain and the lose. Among these, this one is the strongest reducing agent. Among these, this one is the strongest oxidizing agent. The rest are waiting for them to finish. So this is a spontaneous redox reaction. How you will construct the redox reaction? Look, what you will do, you will keep this the same way. It's going in the forward direction. Keep it the same. MnO4 plus 8H plus 5 electron. Mn2 plus 4 water. The E naught value is the same. You will flip it. When you flip this one, it will lose electron, making what? Barium ion. When you will flip it, change the sign, it becomes what? This much. Plus, flip and change its sign. Now, if I want to construct the overall, I have to balance the electron. What am I supposed to do? I will multiply this by 2 and I will multiply this by 5. So what will happen? This is 2 MnO4 plus to 8 is a 16H plus, to 5 is a 10 electron, making 2Mn2 plus 8 water. You will not multiply the E naught value. No, I will tell you that why. Now, multiply the lower by 2 barium. No, not 2, sorry. Multiply it by what? 5? 5? 5 2s are 10 electron. 5 barium. Not multiply it. Huh? What is the overall equation? Cancel the electron, and if anything else is same, it's also cancelled on both sides, right? So, what is your overall equation? 2MnO4, 5 barium, 16H plus, making 2Mn2 plus, 8 water, and 5 barium. And the sum is 0 plus 2 is what? 2. 9 plus 5 is 14. 2, 1, 3, and 4 volt. You know, this is what? The potential difference of the two half cell, E cell. So E cell is how much? Standard E cell plus 4.42 volt. Like that is the potential, like if I make the cell out for this whole equation, like one electrode is of the barium, the other electrode is of the MnO4. If this is my whole cell, the upper one, the potential difference is how much? This is the E cell. How you'll define the E cell? Potential difference of two half cells under standard condition. Under standard condition. Now listen. We can also calculate the E cell using another method. Like it's a potential difference. Like either you will keep it the same, you will flip it and change its sign and take the sum. Look, the forward is same, the flipped one is change its sign, and then take what? Sum. Take the sum of the two. Or what is the other method? Listen. What is the other method? E cell is equal to what? E cell is equal to E cell is equal to E reduced minus E oxidized. Use original values before changing or without changing the sign. For example, in the upper one, E reduced minus E oxidized, the same value. Look, E reduced, E cell, E reduced 1.52 minus 2.9. So what will happen? The minus and minus become what? Plus. Huh? So your answer is what? Still 4.42 volt. So what is your conclusion? In any reaction among the one which are gaining, the one with the larger E naught gain, among the one which are losing, the one with the lower E naught will lose. Now, the one which is gaining, keep it same. The one which is losing, flip it, change the sign and take the sum, right? And you will calculate the E cell. You will calculate the E cell. If the E cell is positive, if the E cell, note, E cell positive means reaction is feasible. The oxidizing agent, low E naught, is sufficiently strong to oxidize the other substance. Large E naught. The oxidizing agent is sufficiently strong. Oh, sorry, I made a mistake. The oxidizing agent with large E naught is sufficiently strong to oxidize the other substance that has low E naught. Huh? The oxidizing agent is sufficiently strong to oxidize the other substance with the low E naught and itself get reduced. Or the reverse argument. Like, I think I'm making this a bit confused. So keep it simple. Definitely, a reaction will only occur when the one which is gaining electron, when its E naught value is higher than the one which is losing electron. The one which is gaining electron, its E naught value is higher than the one which is losing electron. The E cell would be positive, the reaction would be feasible. And there is another way. We can also find the feasibility by using delta G. And you know the delta G is what? The delta G is minus NF E cell. Minus NF E cell. Now, listen. N is the electron transferred. F is constant, 96500 coulomb. E cell, we calculated like this, see? Huh? Like I can do it for this reaction, it's very simple. But one thing that I want to tell you, that you must know, the delta G is what? Kilojoules per mole. Now, F is what? Coulombs. And you know coulombs are what? Joules. Coulombs are what? Coulombs are, no. This is just coulombs. The E cell is volt and volts are joules per coulomb. So if you see, these are electrons, just a number. These are coulombs, these are joules per coulomb. So the coulombs are cancelled. What is left? Joules. Now what you are supposed to do? This is kilojoules and this is joules. So what you are supposed to do? You will divide this by 1000. So delta G is equal to minus NF E cell divided by 1000. For the above equation, in which how many electrons are transferred? 10. It's losing 10, it's gaining 10, so 10 electrons are transferred. E cell is 4.42, minus How you will calculate? Minus 10 into 96500 coulomb, 00, into 4.42 divided by 1000. Your answer is automatically negative. So for any spontaneous reaction, keep in mind, spontaneous and non-spontaneous. E cell is positive, delta G is negative. E cell is negative, delta G is positive. Of course, if it is positive, the positive and negative become negative. If it is negative, negative into negative become what? Positive. So, when you will construct equation, you know the electrons transferred, you know the constant, you can put this and divide it by 1000. Look, what am I doing? Huh? This is electron transferred, this is constant, this is your delta, E cell, and you can calculate delta G. Why you are dividing it by 1000? So that the joules are converted into kilojoules. And next point, I told you that when you will multiply this with 2 and 5, you're not going to multiply this. Why? Because volts are joules per coulomb. So when you multiply 2, when you multiply the electrons, when there are more electrons, there are more joules and more coulombs. When you multiply electron, there are more joules, there are more coulombs because the charge is more, the ratio remains same. So when you multiply, this will not change. So what is your conclusion? That when there is a cell, there will be two half cell, two electrode, at one oxidation and the other reduction. The oxidation and reduction are decided by the electrode potential values. The one with the larger will gain, the one with the lower will lose. The one with the larger that is gaining is going in the forward direction. The one with the lower is going in the backward direction. You will flip it, you will change the sign and take the sum to calculate the E cell. E cell positive reaction is spontaneous, which is the potential difference between the two half cells. This is given by the voltmeter. If you insert a voltmeter, connect a voltmeter, you will get a reading that shows the potential difference of the two half cell. And if you know E cell, you can calculate the delta G. Your next topic is how to construct the cells properly. This I'm going to do in the next lecture. Now, what you're supposed to do? Like and share and subscribe my channel, right? See you in the next class. Allah Hafiz.